Hello everyone, today we're going to have a look at the January 2018 CSEC Math Paper 2. Once again, you will need to have a copy of the past paper in order to follow along with us as we solve these problems. So let's get right to it. So as you can see in question 1A, what we're shown here is a fractions question, just enough to get us started. And this is where we note that the examiners are testing that you understand order of operations. Here we have fraction with two operations. We have a division and addition operation. So we should recognize by now that we should attend to the division operation first. So let's just have a look at that. So we're going to be solving this section bracket I'm highlighting here first. Then we add this third portion of the fraction. So first, we change to improper fraction, and we get 11 over 2 divided by 3 is 9 plus 2 is 11 over 3, and we can invert and multiply quickly and get 3 over 11, where these two would cancel, and the first part of the operation would give us 3 over 2. Next, we will convert this section here to improper fraction and add to this fraction. So let's do the conversion. So the conversion is 5 once 5 plus 4 is equal to 9 over 5. So we add that to 3 over 2, and we have 9 over 5, and we get 33 over 10 as the first part of our solution. Now let us look at the second part of the question. Here we simply need to multiply 0.38 squared by 165. So we simply can look at this as 165 times 0.38 times 0.38, and this would give us 23.826 as our first answer. So next we need to convert this to two decimal places. I'll just write 2dp here for short, and since we want two decimal places, we will look at the third decimal place, which is 6, which means we could up this from 2 to 3, and we're going to be getting 23.83 to two decimal places. Next, we're asked to convert this answer to three significant figures. So we have three significant figures, and 23.826, we have here 5 significant figures. We only need 3. So we look at the fourth digit and we see it's 2, so we can remain as 23.8 to 3 significant figures. And finally, to the nearest whole number, and here we have the nearest whole number would be 24. So let's now go down to part C of question 1, and here we have an investor investing $5,000 for 3 years. And after 3 years, he receives a total amount of $5,810. So the first part of the question is asking you to identify his interest. So that would be 5,810 minus what he started with, which is 5,000. So his interest would be $810. The second part of the question is asking you to identify what this value is as a rate of interest. This is the amount in dollar value. What is the rate of interest? And since it is invested at simple interest, we can use the formula where we have I, which is our interest, is equal to PTR over 100. So if we want to find the rate of interest, we transpose for R. So R will be equal to 100 times I over PT. And we substitute these values in, so we have 100 times our interest, which is 810, divided by the principal, which is 5,000, and the time in years, which is 3, and that is going to give us 5.4%. So our rate of interest is 5.4%. Finally, we're asked to determine how long in years it would take for the investment to double. What does that mean? It means that it would be $10,000 after a certain time, giving his interest then to be equal to $5,000 as well. So we could use the formula we had before, which is I is equal to PTR over 100. And we're asked to determine how long it would take. So we need to find an equation for time t. So we could write simply as t is equal to 100I over P times R, where the rate of interest is the same as before, 5.4%. So 100 times I, where I is your interest, which is $5,000 because it has doubled. And we're going to divide by the principal, which is also 5,000, times R, which is 5.4%, and that works out to be 18.5 years. So in essence, it would take 18.5 years for his investment of 5,000 to double. Moving on to question number 2a, here we have an operation in which we have a star b, which is an operation of a and b, and it is given as being equal to square root of a plus 4b. So if we have 1 star 2, then that would mean a is equal to 1 and b is equal to 2. So we substitute that here. We would get 1 plus 4 times 2, which is equal to square root of 9, which is equal to plus or minus 3. So we're interested only in the positive root, so we will give our answer as positive 3. The second part of question number 2 is asking us to determine whether or not this operation is commutative. This simply is asking us to test whether a star b is equal to b star a. So in essence, in the first part of the question, a is 1, b is equal to 2. So what if we had b is equal to 1 and a is equal to 2? Would that give us the same answer? That is what the question is asking us for. So let's stick that in. So we would have b star a will be equal to, where b is now 1 and a is equal to 2. So it would be equal to 2 plus 4 times 1, and that is equal to square root of 6. This is clearly not equal to 3, therefore we can conclude that the operation is not commutative. Part 2b of the question is to solve an inequality. So here we have 3 minus 2x is greater than 5. So let's transpose for x. So first we'd have minus 2x is greater than 5 minus 3. We're subtracting 3 from both sides. So we end up with minus 2x is greater than 2. Dividing through by 2, you would get minus x is greater than 1. And therefore, the minus sign would cause this inequality to reverse. So we'll have x is less than negative 1. So that's our solution. On a number line, this would mean this is our point minus 1. And since it's a less than sign, it does not make contact with the negative 1. Going in this direction. So this is our demonstration of this value of x on the number line. Let's look at question 2c. The first statement is that if we are to take the cost of an adult ticket as x and the cost of a child ticket as y, then we're given two statements. We're given first that 2 adult tickets plus 3 child tickets would be equal to 43. So we could write an equation describing that situation. So we have here 2x plus 3y is equal to 43. And this is in dollars. Then we're also given that 1 adult ticket x plus 1 child ticket y is equal to $18.50. So what we need to do is to find the values of x and y so we can solve these two equations. So let's refer to this one as equation 1, this one as equation 2. So let us do so by eliminating the variable x. So we're going to multiply equation 2 by 2, and we multiply equation 1 by 1. So this will give 2x plus 3y is equal to 43. And we multiply this equation by 2, so we get 2x plus 2y is equal to, multiply this by 2, and we're going to be getting 37. So when we subtract these two equations this will cancel, and you'll have y is equal to 43 minus 37 is equal to 6. So our first variable, y, is equal to 6. So we can now substitute y, the value of y, into any equation. Let's substitute it into this equation. We have x plus 6 then will be equal to $18.50. Therefore, x is equal to $18.50 minus 6, which is equal to $12.50. So what we have then is x is equal to $12.50 and y is equal to $6. Okay, so here we have question number 3a, where we have three sets, M, P, and R as shown. And we have the universal set, which is all the values within this universe. And we're also shown the relationship between the sets. And in the first instance, we're asked to find the number of characters in the set P union R. So P is denoted here as a red circle, R as the blue circle. So P union R is simply saying how many characters are in both. So all we need to do is count them. So let's count together. So it's 1, 2, 3, 4, 5, 6, 7, 8. So we have the union is actually equal to 8. That's a number of elements in the union of P and R. The second part of the question is asking us to show the set which represents the intersection of M and P. So M is the yellow circle, P is the red circle. So the intersection of the red and the yellow circle is clearly B and D. So we could just write that is equal to B and D. Finally, we're asked to show the elements in the set M and the union of R complement. The first thing I would like to do is I would like to recognize what the set M is and write that down. So let's just write. So M is equal to all the elements in M. So it's K, B, D, and I. And the complement of R, and how do you want to think about this? It is everything that is outside of R. If we take from the left to right, we have W, K, B, V, S, and T. So let's write that down. So now we're looking for the union. M union R complement, which would mean everything included in both R complement and M. So we could start by including everything in the complement of R. So we could just rewrite this one since it's a larger one. So we have W, K, B, V, S, and T. So what else is left? So we have K already, B, so we need to include D and I. So that is our answer. Okay, so for 3B of our question, we have a construction problem to solve. And in the first instance, we are given that we are to construct a triangle PQR, where PQ is equal to 8 centimeters and PQR 120 degrees. So the first thing we would normally do is identify our points P and Q as 8 centimeters. So this would be 8 centimeters. So now that we have P and Q, the next step would be to construct our 120 degree angle, because PQR is 120 degrees. So let's visualize that at Q we would have, and this is just a little sketch to show you what it should look like. So this would be 120 degrees, and if that is 120 degrees, then it means that this angle will be 60 degrees. So we will need to construct a 60 degree angle at Q. So we'll get our compass. The first thing we will do is we will place our compass at Q, and we would extend the compass to a reasonable separation. What I've done is I've actually identified a point 5 centimeters away from Q, because I know that R will be 5 centimeters. So I'm just going to make it 5 centimeters immediately. So at once I will get the point R when I'm finished the construction. So I'm going to strike an arc. Next, I'll place my compass at this point, and I will strike another arc to intersect the first arc. And this point will represent a 60-degree line from point Q. So all I need is to construct a line between Q and this new point. This point represents the point R, and it happens to be 5 centimeters away because I already indicated that between Q and this point, let's call this point P1, it is 5 centimeters. I draw an arc, which means this point is also 5 centimeters. So the distance, both the distance and the angle, are at once correct. So all I need now to do is to construct my triangle by connecting P and R, and that will represent my triangle. We're asked to measure the distance PR, so we could easily use our ruler to take a measurement, and this works out to be 11.4 cm. Okay, so the next thing we're asked to do is to construct a parallelogram, these dimensions. So let us see how we want to look at that. So the first thing we want to do is to visualize what our parallelogram is going to look like. So let's have a look at that. So if you imagine a parallelogram PQRS, it means that if this is point P, then our parallelogram will look something like this. And this again is just a rough sketch to show us what the thing is going to look like. We'll need to construct it, but it is always a good idea to have in your mind what it looks like even before you start your construction. So it's a parallelogram, which means this side is going to be the same length as this side, and this side is going to be the same length as that side. So let us begin our construction. So the first thing we need to recognize is that if I'm going to get the same length, QR is equal to PS, the new point is S, then I can take my compass and I could measure R. So I know I have 5 centimeters here. Then I could move my compass over onto this side and strike an arc to get my first line, which means the distance between P and this first line is 5 centimeters. Now I need to get the other dimension, and that is to measure this distance, PQ. So I use my compass once again, and I get this distance PQ, and I know that this distance PQ is going to be the same as RS. So I move the compass over to this point, and then I strike my other line. This will give me the point S. So I merely need to connect these points and my task will be completed. So let's construct. This is our parallelogram PQ, R, and S. Our next question, 4a, we're given an equation 3x minus 4y is equal to 5, and we're asked to transpose for y. So we will produce an equation in the form y is equal to mx plus c. So let's transpose for y. So let's start by writing what we have, which is 3x minus 4y is equal to 5. So we will move 4y to the right hand side, and we'll have 3x is equal to 5 plus 4y. Then we will move this 5 to the left hand side, and we'll get 3x minus 5 is equal to 4y, and therefore y is equal to 3 over 4x minus 5 over 4. So that's our first task completed. Next, we're asked to determine the gradient of that line. So let's just identify the gradient as the coefficient of the x term. So this would be the coefficient of x, which is our gradient, equal to 3 over 4. So here we have the point P lies on this line, y is equal to 3 over 4x minus 5 over 4. So the point P lies on that line where P has coordinates r and 2. What is the value of r? This is the same as saying if x is equal to r and y is equal to 2, then what's the value of x? It's the same thing we're saying. So we're simply going to substitute r and 2 in the general equation. So we from y is equal to 3 over 4x minus 5 over 4. We're going to substitute this for 2 and x for r. And we'll get 2 is equal to 3 over 4r minus 5 over 4. So we can now transpose for r. A quick way to do this is to use a common denominator of 4. So we change this to an equivalent fraction with a denominator of 4. So that will be the equivalent of 8 over 4, which is the same as 2, is equal to 3 over 4r minus 5 over 4. So now we can write simply as 8 is equal to 3r minus 5. The denominators will pretty much eliminate themselves. And here we get 3r is equal to 8 plus 5. And therefore r is equal to 13 over 3. Finally, for part 3, we're given that a second line y2 is perpendicular to this line, which we can call as y1. It also passes through the coordinates 6 and 0, so we are to find the equation of that line. So two things we need to find the equation of a line. We need to know the slope of the line and the intercept of the line. So we know that the slope of the first line, so let's write slope or gradient if you like, of line y1 is equal to 3 over 4, because we found that earlier. So the slope of this new line that we're trying to find, which we're calling y2, is going to be the negative inverse of y1. So notice what I did. I inverted and I multiplied by negative 1. So this is the slope of y2. So we can now use these coordinates in the general equation with this slope to find the constant c. So we can write y2 is equal to m2x plus c, where this of course is the slope or gradient of line 2. Let's call this as m2. So we have y2. We can substitute these constants in the coordinates. So y is equal to 0 is equal to m2, which is negative 4 over 3, times x, substitute 6, plus c. So clearly c becomes equal to 6 times 4 over 3, which is equal to 8. So the equation for y2, which is the equation of the perpendicular line, is m, which is negative 4 over 3 x plus 8. Let's have a look at question 4b. Question 4b is asking us to plot these two equations on the same graph. So let's just proceed to do that. So let's look at the first equation, which is x plus y is equal to 10. So how do I draw a line on a graph in the simplest way? Well, the first thing I can do is I can set x to be equal to 0, because all I need are 2 points. So I'm going to set x to 0 and find the value of y to get the first point. Then I'm going to set y to 0 and find the value of x for the second point. Let's do that slowly. So for the first point, we're going to set x to 0 and we're going to find y. Therefore, if x plus y is equal to 10, we set x to 0, so we have 0 plus y is equal to 10, or y would be equal to 10 at that moment. So the first point is x equals 0, and y is equal to 10. That's point 1. And we could immediately put that on our graph. X is equal to 0, y is equal to 10. So this is our first point. To find the second point, we're going to set y to 0 to find x. So to do this, we recognize once again that if x plus y is equal to 10, then if y is equal to 0, then x is equal to 10. So the coordinates are 10 and 0 for point number 2. So once again, we take that point here. These are the coordinates of that point. X is equal to 10, y is equal to 0. Then we connect those 2 points. So there we have our first line, and the equation is x plus y is equal to 10. Our second equation, y is equal to x. By now we should have become very familiar with what the line y is equal to x looks like. So again, we need 2 points. So when x is equal to 0, y is equal to 0. So this is our first point. Now let's find the second point. So when x is equal to 10, y is equal to 10. So this line is y is equal to x. So now we're given 4 inequalities that we need to draw on this same graph. So let's just write these 4 inequalities. So the first is x is greater than or equal to 0. Y is greater than or equal to 0. Let's just look at what that looks like immediately. X greater than or equal to 0 and y greater than or equal to 0 is simply telling us that our results are in the first quadrant, which means it is on this side of the graph. Our next inequality is x plus y is less than or equal to 10. So if this line is x plus y is equal to 10, less than or equal to 10 is represented by all solutions that fall below this line. Similarly, x is greater than or equal to y, and we could rewrite as y is less than or equal to x. Same equation written two different ways. And if y is less than or equal to x, then it means that I'm going to look for the line y is equal to x, and the solutions would be found below the line y is equal to x. So when I consider all the variations I have, it means that this region here R would represent all the solutions that satisfy these four inequalities. So if I'm to shade this region, this would be a region of interest R. Let's have a look at question number 5. So in question 5, we're shown an object is an object with 6 sides, and it is referred to as a regular polygon because all 6 sides are equal. So this is a regular polygon, and for a regular polygon, all sides have equal length and all the interior angles are equal. So this is what we would refer to as an interior angle. Now, in the first instance, we're told that the distance of one side or the length of one side is 5 centimeters. And because this is a regular polygon, it means that the distance to the center of that polygon would also be 5 centimeters. So let us recognize that here. So if this is 5 centimeters and this side is also 5 centimeters, then it means that this is an equilateral triangle. So each interior angle is equal to 60 degrees. So first, let us identify this regular polygon. It has 6 sides, so we refer to it as a hexagon. It has a name. 6-sided object is a hexagon, and the perimeter of this hexagon, let's look at that as item number 2. The perimeter is equal to 6 times 5 because each side has a length of 5 centimeters. So the perimeter would be 6 times 5 or 30 centimeters. And the interior angle, let's call this one as number 3. The interior angle of this hexagon, that's right, interior angle. So because this is a regular polygon, it means the distance between this side and the center O is also 5 centimeters. And therefore, this is 5 centimeters, 5 centimeters, then this is also 5 centimeters. This also forms an equilateral triangle, giving this angle to be 60 degrees. So the interior angle of this hexagon is then equal to 60 degrees plus 60 degrees is this angle here, and that is equal to 60 plus 60 or 120 degrees. That's our interior angle. Now we need also to find the area of this object, the area of this hexagon. Let's identify this as item 4, so area of the hexagon. And what we need to note is that if we were to continue by drawing triangles on the inside of this hexagon, we would have a total of 6 triangles. Let's demonstrate. This would be another triangle. This would be another triangle. And these would form 2 other triangles. So if we were to count these triangles, we would note that we'd have 1, 2, 3, 4, 5, a total of 6 triangles. And therefore, if we wanted to find the area of this hexagon, we merely need to find the area of one triangle and multiply by 6. So let's find the area of one triangle. Let's recognize that this is what we're doing. So area of one triangle. And we will utilize the formula which says the area of a triangle is equal to half BC times the sine of A, where this is a general formula for the area of a triangle. But in this case, B and C refer to the length of the sides, and sine A refers to the included angle. So once we have a triangle, and let us look at triangle number 1, if we know the length of the sides, and we know the angle between those 2 sides, which we refer to as the included angle, then we can apply this formula. So in this case, it would be half times 5 times 5 times the sine of 60 degrees. You stick that into your calculator and you would get 10.825 centimeters squared. So area of hexagon then, it is 6 times 10.825, and that is equal to approximately 65 centimeters squared. Okay, let's move on to 5b. Question 5b shows a tank with a uniform cross-sectional area. And that simply means that the sides are uniform. So the area of cross-section, which would be here, is the same throughout the length of this tank. So what do we know? We know that water is poured into this tank, and the rate of the water coming in is 75 cm cubed every second. We also note that the water fills the tank to a height of 2/5 of its total height. So let's call this as 2/5 of h. If after a time of 52 seconds, then we know that the volume of water is equal to 52 times 75 cm cubed per second, and that is equal to 3,900 centimeters cubed. So after 52 seconds, we have 3,900 centimeter cubed of water entering the tank, and because it is a tank of uniform cross-sectional area, we know that 3,900 centimeter cubed of water occupies 2/5 of the volume of the tank. So we could write that 2/5 of the volume of the tank is equal to 3,900 cm cubed. Why can I say this? Because the height is directly proportional to the volume. If the cross-sectional area is uniform, the height will be directly proportional to the volume. So I can say 2/5 of the volume is 3,900. So I could rewrite 2/5 V is equal to 3,900. Therefore, V is equal to 9,750 cm cubed. If we want to state the volume of the tank in liters, we merely need to recall that 1,000 centimeter cubed is equal to 1 liter. Therefore, volume is equal to 9750 over 1,000, which is equal to 9.75 liters. So how do we now find the height of the tank? Well, we know that the area of the tank is equal to 65 cm squared, because we're told that the area of this tank is identical to the area of the hexagon found in 5a, which is 65 centimeters squared. Therefore, we can write volume of tank is equal to area times height of tank. We know the area and we know the volume of the tank. Therefore, volume over area is equal to height, which is equal to 9750 over 65. And that is equal to 150 centimeters. So the overall height of my tank is 150 centimeters, which we can write as 1.5 meters. Recall that 100 centimeters is equal to 1 meter. So question number 6 is a transformation problem, and here we're showing a triangle PQR, and we have identified the coordinates of the vertices PQ and R. So if we reflect this triangle in the line y is equal to 1, so let's just identify what y is equal to 1 is. So y is equal to 1 is a line parallel to the x-axis. So let's just draw this line. So that's our line y is equal to 1. Let's identify it as a mirror line. That's what we call it. So this is our mirror line, and the equation of this mirror line is y is equal to 1. So if we reflect this triangle in this mirror, let's see how we would come up with the coordinates of the image. So what I like to do is I like to count the distance from the mirror line to determine the image. So for example, point P is 1 unit from the mirror line, so its image will be 1 unit from the mirror line on the opposite side. So P prime will be here. So let's just highlight this. So this will be my P prime. Similarly, R prime is 2 units from the mirror line. Therefore, its image will be 2 units on the opposite side of the mirror line, and we know this to be r prime. Finally, q is 1, 2, 3, 4 units from the mirror line, so q prime will be 1, 2, 3, 4 units from the mirror line. So we'll identify this here as well, and then we go ahead and we draw a line to construct the image triangle. So there's our first image triangle PQR, which is a reflection in the line y is equal to 1. Next, we need to reflect this new image in the line x is equal to 0. Now, you need to note immediately that x is equal to 0 is really the y-axis. So let's just draw a mirror line on the y-axis to show. So here's our new mirror line. This new mirror line is x is equal to 0. That is actually the y-axis. So we're going to reflect this object into this mirror line. So let's see what that looks like. So P prime in this case is 1, 2 away from the mirror line. So its image will be also 1, 2 away. This will be on the mirror line, and this one will be here as well. So we can quickly draw this new image triangle. So now that we have our two image triangles, let's label them. So we could call this one P double prime. We could call this one R double prime, and Q double prime. So we're now to describe fully the single transformation that maps this triangle in red onto the original triangle. So let's be clear what we're trying to do. We are going to describe a single transformation that maps this triangle in red to this triangle in white, the original triangle. So if we look at it carefully, we can see that if I were to connect P and P prime, I would actually pass through a new center which is located at x equals 0, y is equal to 1. So what we're having is a rotation of 180 degrees about a new center located at 0, 1. So we could describe this transformation as a rotation of 180 degrees about the point 0, 1. The last part of this question is telling us that triangle PQR, which is this original triangle, undergoes an enlargement with a scale factor of 2, so we should calculate the area of its image. Well, this is not too much of a challenge because we know that after an enlargement, the area of the image is equal to k squared times the area of the object, where k is my enlargement factor or scale factor. So therefore, area of the image is equal to 2 squared times the area of the object. What's the area of the object? This is the object. So let's find the area of this single triangle. So if we take this length as the base, so the length of the base would be 1, 2, 3 units. And we take the height as 2 units. Let's draw this in a different color. This is the height of the triangle. It's 2 units. So area of this triangle is equal to half of the base times height, which is equal to half. The base is 3 units times the height, which is 2 units. So the area is equal to 3 units squared. Therefore, we could write 2 squared times 3, which is equal to 4 times 3, which is equal to 12 units squared, is the area of my image after an enlargement by a scale factor of 2. So question number 7 displays the marks of 10 students in a test scored out of 60. So these are the marks of 10 students. The first thing we needed to do was to arrange the marks in ascending order. So from smallest all the way to largest. So we did this here. So this, let me make the point here. These are marks arranged in ascending order. So we are to determine the range of this data or the marks for the student. So range, so the first one is the range, simply the highest minus the lowest, which is equal to 45 minus 26, and that is equal to 19. So the range of marks is 19. The median mark. So how do we determine the median mark? After we have arranged in ascending order, we merely need to recognize that the median mark is the middle mark or the center mark. So the median is the mark in the center. So is there a center? So let's have a look. We have 10 different marks. Therefore, there is no center. So we'll have to use the 2 marks that are in the center, which means these 2 marks. So we would take the average of these 2 because these are the 2 marks that are now in the center. If we don't have a single mark that's in the center, we'll take the 2 marks that are in the center. How do we know this? If we have an odd number of data, then we'll have a single mark. If we have an even number of data, then we'll have to take the average of the 2 marks that are in the center. So the average of 37 and 38 is equal to 37.5. Next, we need to determine the interquartile range. So let's just abbreviate as IQR. So IQR is equal to the upper quartile, which is Q3, minus the lower quartile, which is Q1. And we'll explain what those mean in a second. So Q3 is the median of the upper half. So if we take this to be the halfway point, then this is the upper half, and this set of marks below is the lower half. So the median is the center mark in the upper half, which is Q3. So let's write Q3 is the median of the upper half. And in this case, we do have a center number, so that's 38. And similarly, Q1 is equal to the median of the lower half. And we do have a center mark, which is equal to 31. Therefore, IQR is equal to 38 minus 31, and that's equal to 7. Part 4, well, we are told that the maximum mark is 60. So let's write maximum mark is 60. So what is the probability that a student chosen at random will score less than half the maximum mark on the test? So if the maximum mark is 60, less than half would mean less than 30. So what is the probability that a student will score less than 30 marks? So all this means is number of students scoring less than 30 marks over all students. So the number of students scoring less than 30 marks, there are only 2 of them. These 2. Their total number of students, there are 10 of them. So it's actually 2 over 10. We could rewrite it as 1 over 5. Okay, so in question 7b, what we're shown is the frequency distribution of the masses of 50 adults prior to the start of a fitness program. The question can be followed very closely if you have a copy of the past paper, because what I've done here is I've summarized the results somewhat, and I've also drawn the frequency polygon, which is part of the question. So let us just walk through what we did. So in the first instance, the masses are given as a range. It is grouped data. So what we're given here is the number of adults who have weights as shown by the midpoint number that you see here. So in essence, 8 adults would have a mass falling somewhere around 62 kilograms. That's the midpoint of the data given. And 11 would have a mass of 67 kilograms. So what we did is we went ahead and we plotted on this graph the coordinates of mass versus adults. So in the first instance, the first coordinate would be 62 kilograms, and that would map to 8 adults, and 67 kilograms mapping to 11 adults, similar to what you see on the coordinates here. Once we got those points, we joined those points using a ruler, a straight edge, and we arrived at this frequency polygon. The important points to note here is that the starting and ending points do not go all the way to the, if you like, the x-axis, and therefore you will have to project these lines down to the x-axis using the same scale as seen on the graph itself. That's not too challenging. Just remember that your starting point typically does not go all the way down to the x-axis. You'll have to draw these 2 lines to complete the polygon. Question number 8a. So here it is that we are given 3 figures and we're asked to complete the 4th figure. Here I have completed the 4th figure as shown in blue. These are the sections that we've added here, as you can see. Next, we're given the pattern and the number of sticks and their perimeters that relate to each figure number that we will call n. So for example, the first figure would have 3 sticks and a perimeter of As you'll see here, 0 plus 1 plus 2 is equal to 3. So what we need to do is to study the pattern carefully to see if we can make some projections as to what an equation would be to calculate sticks and perimeter. Typical sequencing problem. Let's get right to it. So if you notice here, for example, in the first set, the difference between the first and second figure is 4 sticks. Second and third is 4. We can see that it is increasing by 4. We can also look at the perimeter and we can see that this one is increasing by 2 and this is also increasing by 2. So it is telling us that the increase is uniform. We can see that the fourth figure would naturally simply increase by 4, so this would be 15. And this figure would increase by 2, so this would be 9. So if we wanted to generalize on an equation for these two variables, sticks and perimeter, let us see what else we can conclude from this set of information that we have here. Okay, one of the things I'd like to point out real quickly is a simple way to do this is to recognize that we are increasing by a rate of 4. So let's take an equation for sticks. We could start by saying sticks is equal to 4n, and if we step back at the same rate as it is increasing, since it is linear, we should be able to get an indication of where the starting point is. So in essence, if I were to step back from 3, this would be equal to -1. So I could write immediately that sticks is equal to 4n minus 1. This is where I started. This is like my intercept, and this is like my slope or my gradient. So I could easily conclude that if I were to step back by the rate at which it's increasing, then I would have sticks s is equal to 4n minus 1 because it is increasing at the rate of 4. Similarly, this is increasing at the rate of 2. So I could write that perimeter is equal to 2n. And to find out where it started, I could step back by the same rate of 2. 3 minus 2 is equal to 1. So it would be equal to 2n plus 1. And I could generalize my equations quickly and easily as shown. So now that we have equations, if for example we have perimeter is equal to 41, we can always find the number of sticks and n. So let's go ahead and do that. So if p is equal to 41, then we can say that because we know that p is equal to 2n plus 1, and we equate that to 41, then it means that 2n is equal to 41 minus 1, which is equal to 40. Therefore, n is equal to 20. So we know that n would be 20 in this case. And since s is equal to 4n minus 1, so that's 4 by 20 is equal to 80 minus 1. So let's write it's equal to 4 by 20 minus 1. So that would be equal to 79. We're also given a case where number of 6 is equal to 127. And we're asked to determine n and p. So let's write. So if s is equal to 127, which we know that is equal to 4n minus 1, then we can solve for n by writing 127 plus 1 is equal to 4n, and therefore n is equal to 128 over 4, and that is equal to 32. So we could write 32 here, and we could also calculate the value of p, because p is equal to 2n plus 1, so we could write as 2 times 32 plus 1, and that is equal to 64 plus 1, or 65. Let's go on to question number 9. So in question 9, we're given a quadratic equation, and we're asked to show that the solution can be represented as -1 plus or minus the square root of 6. So we're asked to show that the roots or the solution to this equation is actually this value. So let's not get all bent out of shape about what this is. This simply means each quadratic equation has two solutions. The first solution is -1 plus root 6. And the second solution is -1 minus root 6. So these are the two solutions. But what they're asking us to do at this point is to show this. So let's proceed to solve this equation to see if we get this as our solution. So let's go ahead. Let's use the quadratic formula. So the quadratic formula is x is equal to minus b plus or minus square root b squared minus 4ac all over 2a, where a is equal to 1, b is equal to 2, c is equal to negative 5. So let's substitute these values into this equation. So we have x is equal to negative b, so that will be negative 2 plus or minus the root of b squared, so it's 2 squared, and that's going to be equal to 4 minus 4ac, so it's 4 times a times c, so that's 4 times 1 is 4 times negative 5 is negative 20, so, and that is all over 2a, where a is equal to 1, so we could write as negative 2 root of 24 all over 2. So, let us see if we could simplify this further. So we could write that as negative 2 over 2, let's not forget the plus or minus here, plus or minus, and then we could write 24 as 4 times 6 all over 2. All I've done is split this so that I have the negative 2 and the 24 as two separate terms. Therefore, we could have negative 2 over 2 is equal to negative 1 plus or minus. I could split this as root of 4 times root of 6 all over 2. That's equal to negative 1 plus or minus the root of 4 is 2 times root of 6 all over 2. This one would cancel with this one, and the result would be negative 1 plus or minus the square root of 6, and this looks exactly like the solution we're trying to show. The second part of the question, solve two equations. Let's call them equation 1 and equation 2. So we're going to substitute equation 1 into equation 2. So equation 2 is x, y is equal to 5. So if I replace y with 2 plus x, then I get x times y, which is now 2 plus x, is equal to 5. I expand this term and I'll be getting 2x plus x squared is equal to 5. I could take 5 to the left hand side and write as x squared plus 2x minus 5 is equal to 0. So if you notice immediately that this equation, let's call this equation 4, is exactly what we started out with earlier. Let's just highlight it here. Here. These two equations are the same. Therefore, the solution is already obtained as, so x is equal to negative 1 plus or minus root of 6. Already obtained, so we do not need to solve it a second time. So in question 9, we're given a function y is equal to 2 to the power of x, and we're given a table. We're to complete the table and then draw the graph. Let's proceed. So here we have x is equal to negative 1. Then 2 to the power of negative 1 is really 1 over 2, which is a half. So let's put that in. 2 to the power of 0 is equal to 1. 2 squared is equal to 4. 8, 16. So go ahead and plot these values. So here's the first point. 3 corresponds to 8. 2, 4, 1 corresponds to 2. 0 to 1. And negative 1 to the power of a half. We now connect these points. Finally, we're asked to determine the value of x when y is equal to 11. So let's put when y is equal to 11. So when y is equal to 11, identify the point here. We move across until we intersect with the curve. And then we proceed downwards. And we end up with x being equal to 3.4 approximately. So we say when y is equal to 11, x is approximately 3.4. Let's move on to the next question. So question 10 is a problem in circle geometry, and we're given an object and we're asked to find a few angles on this object. At first, this looks a bit intimidating, but let us take a closer look at it to see if we could make some sense out of this drawing. I will use an illustration to demonstrate how we can approach this particular topic. So what I'm trying to do is to get you to extract or to learn to extract meaningful information from what appears to be a fairly complicated diagram. So if you notice, I have drawn here in red an outline of a cyclic quadrilateral. Now notice that this is the same drawing that I have here on the left, which also has a similar cyclic quadrilateral, because each drawing on the right is identical to what we've been given. So let's label this one as number 1. So in the first instance, we have identified a cyclic quadrilateral. How is that useful to us? Because in a cyclic quadrilateral, we know that the opposite angles are supplementary, which means they add to 180 degrees. So if I look at the diagram of number 2, I notice, and I have highlighted what I've also seen as an isosceles triangle. Notice on your original drawing, you have an isosceles triangle. Now, why is that useful to recognize? Because the base angles, these two angles at the base of the isosceles triangle, are equal. So that's useful to know. So we may make use of this information going forward. So for number 3, I have highlighted tangent, a chord, and what appears to be a triangle inside of this circle. But what I'm really after is the fact that the angle between the tangent, this tangent CDE, and the chord CD is equal to this angle here. So if I call this one X, this angle would be X. So both of these angles are equal. In my diagram for number 4, what I've shown here is another chord, AD. From this chord, there's an angle at the center, and there's also an angle subtended at the circumference here at C. So if this is 2x, then this angle here would be x, because the angle at the center is twice the angle at the circumference. And all of these are coming from this original drawing. I'm just trying to make you realize that if you look closely, you can extract valuable information that you will need. For the last illustration, number 5, I have highlighted the two tangents where they intersect at point E and where they subtend from AD at the center. And in this case, we know that these angles, if this is X and this angle is Y, then X plus Y is equal to 180 degrees. So the opposite angles, when we have two tangents arranged like this, they are supplementary. So we are going to be making use of all of these bits of information a little later. But what I wanted you to see here is that look closely on the diagram and you'll be able to extract very valuable information that you can make use of. So our first question is to find angle ACD, which is this angle here. And if you notice, the ACD is the angle that is subtended at the circumference from chord AD. If you notice, chord AD is here, and we demonstrated that earlier in our illustration. This is angle at the center, this is the angle at the circumference. We know that ACD is a half of the angle at the center, which is 114, and therefore ACD is equal to 57 degrees. The second angle we're asked to find is AED. So let us identify that. So this is AED. So this is the angle here we're asked to find. And as we said earlier, AED plus AOB, the angle at the center, those are supplementary. So they add to 180 degrees. Therefore, AED is equal to 66 degrees. Okay, so the next angle we need to find is OAC. Let's identify this angle on our drawing. So notice immediately that this angle plus this angle are part of the base angle of triangle OAD. So let's write, if we give this angle a description, let's call it angle X, then what we can say then is OAC plus angle X is the base angle of triangle OAD. So we need to find the base angle of triangle OAD is equal to 180 degrees minus 114 over 2. That is equal to 33 degrees. Let's identify these angles here. So this angle is a base angle, 33 degrees. And X plus the unknown is also equal to 33 degrees. So we could go back to this point here and write again that OAC plus angle X is equal to 33 degrees. Okay, so what is angle X? Now, if you notice from our illustration earlier, angle X is actually equal to 18 degrees because the angle between the tangent and the chord is equal to the angle in the alternate segment x. So we could write that x is equal to 18 degrees because angle between tangent and chord is equal to the angle in the alternate segment. So that's the angle between the tangent and the chord is equal to the angle in the alternate segment. So x, the denoted angle here, is 18 degrees. So if we write that OAC plus 18 degrees is equal to 33 degrees, then OAC is equal to 33 degrees minus 18 degrees, and that is equal to 15 degrees. So we could put that in as well. So this angle is 15 degrees. So the final angle that we need to find is ABC. Let's identify ABC on our drawing. It's ABC here. Now you will notice that ABC forms part of a quadrilateral ABCD. And we know that ABC plus this opposite angle ADC must add to 180 degrees. And the reason? Opposite angles in a cyclic quadrilateral are supplementary. So all we need to do is to find the angle ADC, then subtract from 180. So how do we find ADC? Well, first let us recognize that angles in triangle ADC must add to 180 degrees. Therefore, let's identify the angles in triangle ADC. So this is this angle, and the unknown that we're trying to find. So we could write that 180 degrees, angles in the triangle, must be equal to 18 degrees plus unknown angle we're interested in, plus 57 degrees. So we have one unknown in this equation, where ADC then works out to be 180 degrees, subtract 18 degrees and 57 degrees, and we are left with 105 degrees for the angle ADC. So now that we have ADC, we can find ABC simply by recognizing that ABC then is equal to 180 degrees minus this angle ADC, 105 degrees, and that's equal to 75 degrees. So that completes question number 10. Okay, so 10b is a cuboid that is shown here, and the dimensions are given. So we have the top of the cuboid, it's P, Q, R, and S. So let's write S here, and we're asked to find the length of the straight line connecting R to P. So let's just sort of like visualize it for a second. So this line is connecting R to P. So that's a line going straight across like that. Let's draw that line. So the first thing you probably should note is that this is a 3D drawing, which means that this is actually 90 degrees. Therefore, if this is 90 degrees, this is 100. Therefore, this is also 100. And therefore, all we're asked for is RT, which is this line, is really the hypotenuse of a right-angled triangle with base 60, height 100. So we could write RP squared is equal to 100 squared plus 60 squared, and therefore RP is equal to square root of 100 squared plus 60 squared, and RP works out to be 116.6 centimeters. So we could write that in. So that's RP. Okay, so next we're told that if we take the line, this red line from P, and put it down to T, what would be the length RT in this case? So let's take the line and put it down there, see what it looks like. First, in order for you to visualize this, I've also drawn another figure here. So let's just take this figure down here for a second. Just bear with me for a second, I want to make a point. Okay, so what I've done here is I've simply introduced a little bit of visualization assist, because a lot of students might not see exactly the next move we're going to make. So what I'd like you to do is recall what we've done so far is we've taken a line from R to P, which is this red line, and we've actually drawn a new line which is effectively moving this line all the way from P down to T. So it has now moved from P down to T. And how I'd like you to visualize this is to imagine that this cuboid is a slice of cheese that I've cut along the diagonal. So what you're seeing here, this white face, is the face of the cheese if you cut along that diagonal. So what we're doing now is we're actually drawing a line from one point on the diagonal face to the lower point on the diagonal. That is essentially just the hypotenuse of another right angle triangle, because this face would actually represent right angles, and therefore RP, what we just found, would now be the length, 20 would be the height, and RT would now be the new hypotenuse. So RT squared would now be equal to RP squared plus 20 squared, using Pythagoras again. So RT squared is equal to 116.6 squared plus 20 squared, and therefore we take the square root of that for RT, and that works out to be 118.3. So this length along this diagonal face is 118.3. I'm hoping you're all seeing that. So now we're asked to determine the angle TRV. So we're asked to find this angle. So we know this height is 20, therefore this height is also 20. We know the hypotenuse of that face. We have a lot of information about that face. Since we have this 20 here, we could say the cosine of this angle, let's call it x. If we say that x is equal to TRV, we could say the cosine of x is equal to adjacent over the hypotenuse. So we could write as 20 over this new line RT that we just found, which is 118.3. Therefore, we could write that x is equal to the inverse cosine, written as cosine to the minus 1 of 20 over 118.3, and that works out to be 80.3 degrees. So that's our angle x, or it is the angle that we're looking for, which is TRV. So we can say that the angle through which this wire moved when it moved from P to T is equal to 90 minus 80.3, which is equal to 9.7 degrees. And this is also the same angle here. As you can see on this face, this would be the alternate angle to this one. So we could say that PRT is the same as RTV. Let's have a look at the vectors question number 11. So here we are given three vectors, and we're asked to determine the vector OQ. So we need to find a vector OQ given these vectors. So let's make a simple sketch of what we have here. So I like to make a sketch because it helps me to visualize what I'm doing. So this is my Y, this is my X. So O is the origin. So OP is 3, 4. So I'm going to go out by 3 or by 4. So P is somewhere here. So let's draw the vector. P is the vector OP. And then PQ is negative 1, 2. So I'm going to step back by 1 and go up by 2. So Q is somewhere here. And the vector PQ would look like that. And we're asked to find OQ. So let's just imagine what that looks like. So OQ is the vector going from O to Q. So let's just draw that vector here from origin to Q. And we note that this is a vector O to Q. So if we want to find OQ, it's a simple matter of walking from O to Q along the other vectors. So I am at O and I'm going to Q. So I'm going to walk along the other vectors to get there. So I'm going to go from O to P. So I'm going from O to P, and I'm going to add PQ. And I have vectors for those. So I can write OP as 3, 4 plus PQ is negative 1, 2. I sum those two and I have 2, 6. So we are now introduced to a new vector RS, which is 1, 3. And we're asked to show that RS and OQ are parallel. This is OQ. Well, this is simple enough to show because all we need to show is that OQ is equal to some constant times the vector RS. That is the proof that they're parallel. So if I can show that, then we are well on our way. So let's consider OQ. We know that to be equal to 2, 6. We could take a factor of 2 and we have 2 into 1, 3. But 1, 3 is the same as RS. So we could write that as 2 times RS. So at once we can see that OQ is equal to 2 times RS. And therefore, that's a proof that they are parallel. Question 11b is a case where we will apply vector techniques to a geometrical shape. Here we have a triangle x, y, z, and we're told that the vector x, y is equal to a, the vector y to z is equal to b, and m is the midpoint of x, z. So we're asked to find in terms of a and b, x, z, and my. So first let's find xz. Now we are trying to find xz, then the vector going from x to z is equivalent of going from x to y along this path and from y to z along this path. So we could write that x to z is equal to x, the vector xy, plus the vector yz. So we know that xy is equal to a and yz is equal to b. So xz is then a plus b. So this is our first equation. Next, we need to find the vector my. Let's identify that here. So my is a vector going from m to y. So the direction is important. And so we will label here as well. This is a vector my. So once again, to go from m to y, we will go from m to z in this direction. And then we will go from z to y in this direction. We are at m and we're going to y. So we move along m to z and then z to y. Let's write that as a vector. So we could write as my, the vector my, is equal to first m to z plus z to y. We know that m to z is equal to a half x to z because we found that earlier here. So we could write that as half of a plus b. So that's m to z. Now we need to find z to y, and we can write that as equal to, notice z to y is opposite of the vector y to z, which is b. So z to y is the inverse vector, or minus b. We're going in the opposite direction, so we attach a negative sign to indicate that. So now we have expressions for both terms. We can write m to y is equal to a half a plus b minus b. So we could simplify. We have half of a plus a half of b minus b. So we can now simplify further by writing as equal to a over 2 plus b over 2 minus, and we will change b to an equivalent fraction with a denominator of 2. So that would be 2b over 2. That's the same as b. We're just changing to an equivalent fraction, so we have all terms with a denominator of 2. In that case, we can add and subtract easily. So we have a over 2 minus b over 2, which is the same as a half of a minus b. Let's move on to the next question. Okay, so what I want to do here is to recommend a technique that you should use when you're doing matrix multiplication. Why am I recommending this technique? Well, most people can do matrix multiplication, but it's easy to make errors. So what I've discovered is that if you were to hide the elements that you're not using, it makes life a little easier. You make less errors. So let me show you what I mean. So here I have two matrices, A and B, and what I want to do is multiply these two matrices to get a third matrix, which I'm going to call matrix C. So let's just identify the elements of C. Let's call this one C1, C2, C3, and C4. So how do I get C1? Well, typically I would take the row 1 matrix A and the column 1 of matrix B, and I would multiply those together. So I would get C1 would be equal to 5 times 6 plus 4 times 1, and that would be equal to 34. So C1 would then be equal to 34. So all I'm doing here is multiplying these two sections shown in green. So I don't really need to see anything else while I'm doing that, because this is where the errors are made. So if I were, for example, to cover up those elements that I'm not using, let me demonstrate. So what have I done? I've taken two fingers and I have covered up the elements that I'm not using in this exercise to find C1. So the only numbers I'm going to be using are 5, 4, 6, and 1. So I'm going to hide or cover up the other two numbers so I don't get confused while I am looking at it. So there I can see very easily that C1 is 5 times 6 plus 4 times 1. I could even do this mentally. So let's find C2 using that technique. So in order to find C2, I've simply covered up the elements that I'm not using. So I'm only interested in row 1 and column 2 of B. So I can do this mentally. I could say that C2 is equal to 5 times 7 plus 4 times 3, which is really 35 plus 12, and that is equal to 47. I can do the same thing for C3. So for C3, I've covered up row 1 and column 2 respectively, and mentally I can just simply note that C3 is equal to 3 times 6 plus 2 times 1, and that's equal to 20. I could do that mentally. And of course, if I cover up the elements I don't need for C4, then I could write as C4 is equal to 3 times 7 plus 2 times 3, which is equal to 21 plus 6, and that's equal to 27. So my final matrix is 34, 47, 20, and 27. I'm merely showing you this technique because it has helped me a lot not to make errors. I no longer make errors when I'm doing matrix multiplication, and initially that was not the case. So let's have a look at 11C. 11C is a matrices question, and in the first instance we're asked to determine inverse of the matrix A, and by now we should note that inverse of the matrix A written as A to the minus 1 is simply equal to the adjoint of the matrix A over the determinant of the matrix A, where the adjoint of A, let's just call this one ADJ, is equal to, we take the matrix and we interchange the leading diagonal elements. So 2 goes up here, negative 1 goes down here. So let's just demonstrate. So we switch around the leading diagonal element. So 2 goes up here, negative 1 goes down there. Then we change the sign of these two non-leading elements. So this remains as 0 and this remains as negative 3. So that's our adjoint matrix. And our determinant is simply the product of the leading diagonal elements minus the product of the non-leading diagonal elements, which becomes negative 1 times 2. You subtract 3 times 0, so that becomes equal to negative 2. So A to the minus 1, or the inverse matrix, is equal to 1 over negative 2 into 2, 0, negative 3, negative 1. So this is the same as this matrix divided by negative 2. So that's what we're doing here. This is the same as 2, 0, negative 3, negative 1, all over 2. So I've just rewritten this form. Next, we're asked to show that the inverse of A times A is actually the identity matrix. And we have seen this many times. It comes up a lot in the exam, so become familiar with how to do this. So now that we have this, and we have A, we merely need to multiply them together. So 2, 0, negative 3, negative 1. And we have the negative a half here. Multiply that by the original matrix A, which is negative 1, 0, 3, 2. And when we have a half outside as a factor, you can leave this for last. Really simplifies the arithmetic if you do this. So this works out to be, and I'm going to leave the multiplication because I imagine that you guys are very familiar with this. So this works out to be negative half into negative 2, 0, 0, negative 2, and that works out to be 1, 0, 0, 1. So next we're asked to determine the matrix A squared, which is simply the matrix A multiplied by the matrix A. This works out to be 1, 0, 3, 4. I'm assuming that you're familiar with matrix multiplication, so I'm just showing you what the answers are and how we approach this. So by looking at these two matrices, we can conclude immediately that we cannot multiply A times B. We can't multiply these two matrices. Why? Because for you to multiply two matrices, the number of elements in the row of the first matrix must be equal to the number of elements in the column of the second matrix. So if you notice, the number of elements in this row of this first matrix is 2. The number of elements is 1, 2, 3. So because they're not identical, I cannot multiply those two. So you should be able to express that in words. The number of elements in the row of the first matrix must be equal to the number of elements in the column of the second matrix for the multiplication to be possible. And in this case, they are not the same. Therefore, matrix multiplication is not possible. However, notice, although I can't do A times B, what about B times A? What about this consideration? So let's have a look at this one. The number of elements in this row is 1, 2. The number of elements in this column is 1, 2. So this is possible. So A times B is not possible, but B times A is possible. And the size of the matrix is found as follows. So if I have a matrix B times matrix A, I merely need to look at the size of the matrices to see what the product will look like. I'll show you how to do this immediately. So A is a 2 by 2 matrix. So it's a 2 by 2 matrix. And B is number of rows times number of columns. So I have 3 rows. So I have a 3 by 2 matrix. So I need to multiply these two. So this is what I'd like you to pay attention to, because once the two inner numbers are the same, this tells you whether or not you can perform matrix multiplication. The net result after multiplication, however, are the two outer numbers. So you would be getting a 3 by 2 matrix as a product. So once again, the inner numbers determines if multiplication is possible, and the two outer numbers gives you the product of the final matrix after multiplication. Okay, so for example, just for argument's sake, we had a matrix, a 10 by 3 matrix, and we were going to multiply that by a 3 by 11 matrix. Is multiplication possible? So we would look at the two inner numbers. They are the same. They are 3. Yes, it's possible. So we pass this check. What would be the order of the final product? It would be a 10 by 11 matrix. That would be your final product. So yes, it's possible. Final product will be 10 by 11. So that's just something that you maybe want to keep in mind. And I think this brings us to the end of this particular exam. Hope you all learned something. So see you next time.